Hi, everyone. Excited to be here. My name is Arick Goomanovsky, and I'm the Chief Product Officer and VP at Tenable Cloud Security, where we're building state-of-the-art technologies to help organizations protect and secure their cloud infrastructure environments. And we're here today to talk about CNAPP, Cloud Native Application Protection, which is just one small acronym for cloud security, but is a giant leap forward in security teams' ability to scale and to protect large-scale modern cloud infrastructure environments. And what we would like to start with today is talk a little bit about why securing modern cloud infrastructure is such a challenging task and why there is actually a new opportunity, why it also creates a new opportunity for security teams to modernize their toolbox. So let's start with maybe a few challenges and then talk about the opportunities. First of all, cloud infrastructure environments are complex. We're not only talking about public cloud, we also have our traditional private cloud environments that, when coupled together, create what we call hybrid deployments. And we have different types of virtualization. Kubernetes is getting larger and larger traction with our organization adopting both managed and self-managed Kubernetes environments, whether in the cloud or on-premise, and those environments tend to be very tightly integrated. So really getting good visibility and understanding what happens across your cloud infrastructure is a challenge. Another point is because all that is so complex, you might find yourself facing a lot of small issues, we call them misconfigurations or vulnerabilities, kind of scattered across your entire cloud footprint. And being able to properly prioritize those issues to make sure that you actually able to hone in on the important issues and make those issues bubble up on your visibility stack is super important, right? How do you make sure that you identify the most important problems and you prioritize those problems accordingly so they actually bubble up and are not being kind of lost in the noise of all the small and minor issues you might have in your environment. That's also another issue, right? Another challenge, this noise. Now, obviously, these are all security issues, but you also have compliance challenges. And when you're utilizing public cloud infrastructure, hybrid cloud environments, Kubernetes, understanding what really compliance requirements mean in those environments, and how can you ensure that you're compliant with standards like HIPAA, GDPR, NIST, CIS, or CSA are very important. And it's not easy because sometimes those standards are not extremely prescriptive. They don't really tell you in technical terms what you have to look for, and you have to translate general compliance requirements, like, for example, zero trust or least privilege, into specific technical items that you can go and apply to your environment. And that's also a challenge. And last but not least is the challenge of ownership. We all know that the biggest challenges are never technological. They're usually tend to be organizational or process focused. And cloud infrastructure, the introduction of cloud infrastructure and the adoption of cloud infrastructure created a major shift in way organizations build applications. In your traditional on-premise environments, the teams that would actually own the infrastructure would be the IT. And when a developer needed a new server for the new application that they were working on, they would create a ticket in whatever IT management platform that they were using. The ticket would go to the IT would spin up a server, hand the credentials to the developer, and voila, they can go and build their new application. In the cloud, the developers really own the infrastructure. They actually code this through infrastructure as code. So the developers can actually go and spin up infrastructure independently, and they manage the infrastructure. So that obviously creates a visibility challenge and governance challenge for the security teams because everything is owned by developers. That's one. But secondly, if they identify an issue, how do they actually communicate that to the developer who's not part of the IT? And how do they empower the developer go and solve that problem when developers are not always measured on security? They measured how fast they deploy new features to production. So actually helping security teams and developers breach that growing gap, that growing chasm between those different organizations is also super, super important. as a result of all that, we see that organizations, have problems with staff training, have problems with maturity. 80% of the organizations are on a lower level of their cloud security maturity, and that's a challenge. Also, a lot of organizations, adopt multi-cloud strategies, and that also creates a challenge because you can't train all your employees on one cloud infrastructure environment. You have to empower them to be knowledgeable about a multi-cloud or hybrid environments as a fact. Now, these are all, great challenges to address, but cloud infrastructure also offers a new approach or offers opportunities. And the opportunity lies in the fact that a lot of information can be gathered from cloud service providers' APIs. In your traditional on-premise environments, if you wanted to get information about networking, you have to integrate with network security solutions like firewalls. If you wanted to get information about servers, you have to deploy an agent on the server. If you wanted information about identities, you have to integrate with the IDPs. In the cloud, you can get a lot of information directly from the cloud service providers' APIs. So you can get actually the broad context pretty easily, and then you can integrate that in a smart way. And this is exactly what cloud native application protection platforms designed to do. Again, going back to the challenges, there are a lot of issues, right? Every element of the cloud stack, whether it's networking, whether it's compute, whether it's workloads, whether it's data or identities, is extremely complex. And you have to build expertise in each and every part of that as a CNAPP platform. If we look, for example, at the identity layer of the cloud stack, you can see that in AWS alone, there are thousands or maybe millions of different permissions, creating an enormous set of permutations and cloud access challenges that organizations really have to understand in order to be able to identify issues in the identity part in itself. But then you also have to marry that with the networking configuration, with the workload protection, et cetera, to really drive insight, right? So we understand the problem and we have a way towards a solution, right? So here's a great example, what a cloud infrastructure looks like, right? You have different services in the cloud, you have different elements of your network or different parts of the environment. That could be a hybrid environment, a multi-cloud environment. You have access from the internet, you have users, you have your identity providers, right? It's super, super complex. And as we said, you might have a lot of issues, right? If you deploy a CNAPP solution or an old school cloud security posture management solution that would look for cloud misconfigurations and maybe some vulnerabilities, you would find millions or at least, thousands, if not hundreds of thousands of issues. How do you prioritize? And the solution is actually by cleaning together all that rich context that you can bring from across the stack, by looking at, your network, your identities, your workloads, and bringing that insight from across the stack and looking for what we call toxic combinations, where you have the same resource that has different types of vulnerabilities that when combined together pose a real threat to your environment. So bringing that context together, understanding the vulnerabilities you might have in your cloud workloads, understanding their network exposure from a misconfiguration perspective, understanding their privileges in the environment, bringing that context together can really help you identify realistic attack scenarios against your environment. And once you have those realistic attack scenarios properly identified, that's how you can prioritize those issues for the remediation. So if you have, for example, a situation where you have a compute resource and that compute resource is exposed to the internet directly through a network misconfiguration, and it also has a critical vulnerability, that is a toxic combination because someone can actually try to access that machine from the internet because of the networking exposure, and then try to leverage that vulnerability in order to compromise that machine and take over that machine. Now, the toxic combination does not have to stop there, because if now this machine also using a sensitive privilege role or sensitive service account in the environment, the threat actor that compromised the machine could leverage the access to that service account in order to compromise sensitive data stores in your environment and exfiltrate that data to the internet back to the threat actor. And this is a classic example of a toxic combination because this compute resource has both network exposure, which addresses a networking layer, a workload vulnerability, which addresses the compute layer, and a privileged service account, which addresses the identity and access management layer, right? And once we've identified that combination of risks, obviously that should bubble up and tell us, hey, focus on this first, remediate that first. Because if I have the same story, critical vulnerability on another machine that is not exposed to the internet or not linked to a privileged service account, yes, it's an important issue. It might be a compliance violation, but it poses less risk to your environment and therefore should be prioritized lower than this high critical toxic combination. But is it enough? No, we talked about this growing gap between security teams and developers that actually own the infrastructure. So it's a challenge. If we go back to this machine and we've identified all these issues with that machine, and now we want to send this ticket with that problem to a developer, how do we know who the developer is? How do we know who is the resource owner that should get that finding? And what platform does this resource owner use so we can send the finding in the right way? So identifying the resource owner is a super important task. And here at Tenable, we've been investing a lot of years of research in order to help organizations to manage and identify resource owners automatically. But that's not the end of the story. Some resource owners are using Jira because they're developers and they're used to getting their tasks through Jira tickets. Some might be using ServiceNow. Some might be using Slack, Teams, numerous other platforms, right? So you have to know which platform the right person is using and send the insight or the ticket in the right way to that person for that person to be able to go and pay attention to that and actually address the issue. But that's also not enough because you're not only want to put more work on the plate of your developers, of your DevOps, of your security teams. You want to actually take work off their plate. Because if you send an issue to this developer and you tell them, hey, you have an overprivileged role here, go fix that, by and large, they wouldn't know what they have to do. You don't only want to send them insights, but you also want to help them resolve the issue. And you have to be able to use a solution that tells them how to go solve that issue and not in a generic way by saying, hey, remove sensitive permissions, because they might not know what these sensitive permissions are. You have to give them a solution that they can, with a click of a button, go and apply to their cloud infrastructure environments, or what even better, with a click of a button, create a pull request on their code repository, which they use to define that cloud infrastructure environments. So we're not only talking about integration and direct resolution in the cloud infrastructure, but we're also talking about integration with infrastructure as code and other code repositories. Obviously, if we're talking about a vulnerability, you might want to create a pull request on a container registry or what have you, right? So that's a very important part of the story. So let's talk about what does a unified cloud security strategy look like. You obviously have to start from the basics. You have to discover and look deeply into your multi-cloud environments. You have to continuously discover identities, infrastructure configurations, workloads, data access permissions across your infrastructure, and not only discover those, but also visualize that in an intelligent way that would empower your cloud security teams and your developers to understand where the problems are and what the resolutions should be. It's not only about generating long lists of reports, it's about generating meaningful visualizations that people can act on. The second part is obviously to identify the right risks and make those risks bubble up. So the toxic combinations here play a very important role. And the first example that you see here is exactly the example that we just discussed at great depth. But there are other examples as well. For example, third-party applications that have access to sensitive data within your environment is a great example of another toxic combination. Obviously, once you have identified those issues, you want to be able to prioritize them by criticality, and you want to point your personnel to the most important issues and help them remediate those. The next point is obviously helping users go and remediate. And as we were saying, tell them, hey, you have an issue. This is not enough. You have to tell them, hey, this is your current solution, and this is what good looks like in your cloud infrastructure environment. That what you should apply to your cloud infrastructure environment and help them either push that directly into their cloud infrastructure or help them create a pull request on their code repository so it goes and remediates the problem at its core, at its source in code. Now, obviously that would help you drive security, but it would also help you drive compliance and enhance your compliance footprint, reduce your compliance issues, and help you drive your business forward, right? So we're not only talking about the security use case here, we're also talking about the compliance use case here, which is an important business enabler, as we all know. And last but not least, the cherry on the icing is helping you drive towards zero trust by adopting list privilege, identifying those IAM issues, those permissions that are beyond what users actually require, helping them right-size permissions, or helping them adopt what we call just-in-time principle, where people are not having a long-standing high privileges to the environment, but granted permissions as they need, the privilege access management for the modern era for a cloud infrastructure, if you like. So these are the 4 core steps. You want to start, again, with discovery, prioritizing risk, remediating risk, driving compliance, and resolving your IAM issues. And with that, I would like to thank you and welcome you all to this great event. From me, Arick Goomanovsky, Chief Product Officer for Cloud Security at Tenable, thank you and welcome.